All right, guys, so we are going to be starting the next part of our project, which is drawing a scale version of a giraffe. So scale is when we take something of a certain size and we either enlarge it or we make it smaller. So if you're looking at this taco, we would say that we have scaled it down if we take it and we make it tiny. Or we can say that we have scaled it up if we make it bigger. So this is an example. So like I just said, so this is scaling up and this is scaling down because we've shrunk it on down. So imagine you guys, you're going to be drawing this giraffe, right? Here's my giraffe. Okay. Is this the world's worst giraffe drawing that you've ever seen? Oh my gosh. Is it getting worse? It's getting worse. Oh, and there's his little tail. Okay. So if I draw this giraffe, now this giraffe, okay, on the projector screen, how tall is this thing? Maybe like 2 feet tall or something on your projector screen. Obviously, a giraffe is not 2 feet tall. They're way taller than that, right? So on my little computer screen, as I'm recording this, it's not 2 feet tall. On my little computer screen, it is even smaller. It's like 3 inches tall. So it's like very, very scaled down. So scaling up and scaling down can be a really useful way of representing like really large ideas on like on paper, for example. So let's think about like an architect. An architect is someone who takes drawings of buildings and they plan them all out and get beautiful, beautiful like homes and hospitals and all kinds of things. And they create what are called blueprints. Now, these blueprints are not actual like life-size this isn't the size of a house, right? A blueprint is just a scaled down or smaller version of what is going to be made in real life. So architects use scale to create miniatures, either three-dimensionally or two-dimensionally of what they're going to be building in real life. You guys have probably seen things to scale in science class. If you think about the planets, obviously, like Jupiter's not sitting in your 6th grade science class, right? You see, whoa, sorry, let me redraw that. You saw lots of scaled down versions of our solar system on your science presentations or on in your science textbook. So we scale things down a lot of the time. We can also scale things up. So this year in science, you guys are going to be learning about viruses. So as 7th graders, you're going to be learning a lot about what's called pathology and viruses. And, a virus is not this big. It's actually like microscopic, right? So we take something that's really, really tiny and we can scale it up so that it's visually easier to see. That's what a microscope is really helping you do, is see something that's super, super tiny and make it bigger so that your eyes can actually see what's going on. So let's say that we have this taco here. And I tell you that this taco is 5 inches across. And then this taco, I'm trying to figure out just how big it is. Now, I tell you that when I scaled this up from the 5-inch taco, I made it twice as big. So when I scaled up to this large taco from my 5-inch taco, how big did this guy become? Well, all I'm doing is I'm taking my 5 inches and I'm multiplying it by my scale of 2. So I have 5 inches and I'm scaling it up by 2. That means that this taco right here has to be 10 inches long if it's scaled up by 2. Okay, so let's say same taco, 5 inches, but now I'm telling you that to make this one smaller, I scaled it down by a half, something like that. I split it in half. So what I've got now is my 5-inch taco. Now he is being scaled down by a half. So this isn't going to be 5 inches or 10 inches. It's going to be 5 split in half or times a half. So 5 divided by 2 is 2.5 inches. So that's how big that one would have to be. Let's do a different one. Let me get a different image in here so you guys can get some more practice here. So let's delete my tacos. Let's see. No more tacos. What should we try? Should we try... Oops. Hold on. Let me do it this way. Insert image, search the web. Wow. It really doesn't want me to close it that way. Okay. Cat transparent. Okay. Ooh, there's that cute. No, let's use this one. Cute. Okay. This sitting cat. All right. I know a lot of you guys have cats. Okay, so here's our real life cat. So a real life cat, let's say that when a cat's sitting, I mean, they're not super tall, right? Maybe they're, I don't know. Let's say that this cat is 1 foot tall. Okay, so there's my cat. For when it's sitting, it is 1 foot tall. Now, what I'm going to tell you is that I want to scale this cat up by, let's do huge. Let's say that I want to see a drawing of a cat that is 4 times this size. So I want to scale this up by 4. How tall is this cat going to be? That's right. It would be 4 feet tall. That cat would be 4 feet tall. Now, maybe you don't want a giant cat. Maybe you want an itty bitty cat. And so let's say that this little cat, he shrunk way down. Okay, so let's say that he's that small. Well, let's say that he's just like, I don't know, 1/3, 1/8 of the size. Let's say 1/8. He's real tiny. Okay, that means that he's not 1 foot tall. He'd be 1/8 of a foot tall, right? We're scaling up, we're scaling down. Okay, so you guys are going to get some practice with that. You can see that if you start with a certain height, you can either make it really tiny or you can make it much, much larger. We're going to begin this today, and we'll talk about this more tomorrow too.